All right, lecture 10. I'm going to move very fast here because you have pause and you have rewind. You can look at this over and over again. So I'm just going to go through them, each of these problems, pretty rapidly. So convert 178 liters to decimeters cubed, centimeters cubed, mils, cc's, and gallons. Well, first thing you should know is 1 liter is equal to 1 decimeter cubed. So that means that 178 liters equals 178 decimeters cubed. And 1 liter is equal to 1,000 centimeters cubed. But 1 centimeter cubed, it's on there, is equal to 1 mil, which is equal to 1 cc. A cc means cubic centimeter, and that's what this is. So 1 liter is 1,000 centimeters cubed. It's also 1,000 mils, and it's also 1,000 cc's. On an exam, sometimes it's considered a trick question. It's not. You just have to know these different units. There's lots of them for volume that are used in science and in the medical field. A lot of other fields. So everybody uses their different units of measure. So, and then we have 1 liter is equal to 0.264 gallons. So answer the first question here. So 178 liters, let's put L. 1 liter is 1,000 centimeters cubed. And it will, once we find this answer, it will also go for the next two. And 1 liter equals 1,000 centimeters cubed. That is exact. So we'll have 3 significant figures for our end. And this would be 178,000 centimeters cubed. Since we had only 3 significant figures to start with, we should end with 3, so we have to put it into scientific notation. So we have this for our answer, but that's also 178 liters is also 1.78 times 10 to the 5th mils, and then 1.78 times 10 to the 5th cc's. Just to cover all of the possibilities. So we've done decimeters cubed, centimeters cubed, mils, cc's, now gallons, 178 liters. And then as it's stated above here, 1 liter is 0.264 gallons. We'll just write it GAL. And that's not exact. When you go from metric to English units, generally the relationship is not exact. There's one that is, though. 1 inch is 2.54 centimeters. That one is exact. Not that we're going to use it here, but just to mention it. But most of the time, they're not exact. You have to be told that. In this case, they're not. So we have 3 significant figures. Luckily, they gave us 3 up here. Make sure I'm on here. And so if they had given us, this had been 1.0 and this had been 0.26, then we could have only had 2 significant figures for our answer. So 178 times 0.264, this comes up to be 46.992, and we only have 3 significant figures, so we're going to have to round it to, well, we'd go here, that's going to turn it, so this would be a little tricky when you have the 9s. Just remember that once you add a 1 here, because we have to, due to this digit, then we have to roll it over to this to the 6 as well, so we end up with 47 gallons. And as I said, I'm going to go through quickly, so if I make a mistake in the final calculation, a calculator error, let me know. But if you do it out, follow everything that I do and came up with a different answer, double check it, but then that would be right, and I made a mistake somewhere. But don't want me doing is double and triple checking and spending hours total on that over the course of the next 100 lectures or so. But if I make a mistake, let me know. All right, now we have now the volume is a derived unit because we have to make it up from SI units. Volume is taken from length cubed. So, and same for density. Density is taken from mass and volume. So volume was a derived unit. We had to start with length and cube it. So density is a doubly derived unit. And we're going to use this. Density most often has units of grams per mil. But any mass and any volume units can be used. And we're going to kind of switch around with that as we go, just to make sure that I cover every kind of problem that we could potentially see for density. So the first question here, 5 grams of metal is found to have a volume of 0.879 centimeters cubed. What is the density of this metal in grams per mil? Probably the best thing to do is just find the density with the units that they've given us and then convert. This one will be easy, but we have the mass, so 5.00 grams goes on top. The volume is 0.879 centimeters cubed. So 5 divided by 0.879, and we end up with 5.688, we're going to round to 5.69, and grams per centimeters cubed. And we know that centimeters cubed are mils, so we get the same number with different units, and that's what they want. So be careful when they ask for whatever units they want, give those to them. In this case, it was pretty easy to convert. Okay. Now, let's try some different forms here. We have a compound that has a density of 6.11 grams per mil. What is the mass of 1.67 liters? So, we're still using this formula, but they've given us the density and they've given us the mass. So, they've given us the volume, they want us to find the mass. So, mass, if we rearrange this equation, mass is going to be the density times the volume. If you're ever in doubt, just work it through. Make sure you use the units of measure and you're going to be fine, because it'll let you know if you've made a mistake as you go along. But we're given the density in grams per mil, and then we have to, if we multiply by the volume, we end up with something a little odd looking. We have the grams per mil times liters, so those won't cancel. So you can see that the best thing to do here, I said to wait till the end to change units, but here it's better to change to mils first before we do the calculation. So 1.67 times 10 to the third mils. We have to keep the same number of significant figures, so we have to change the scientific notation. So there's a lot of guidelines that I'm going to give, but depends on the problem. Sometimes it's easier to do a change or manipulation first before we start the calculation. Sometimes it's better to do the calculation and then do the manipulation at the end. Now notice the volume units cancel now. We're left with grams. We wanted mass, so we're good. We have the right units. If we have the right units, then we should come up with the right answer. You always want to carry your units through to double check. Now let me just write it out what I have on my calculator. Well, we have 3 significant figures, so we need 3 here. We have to chop it here, so this is going to be, it's best to, well, you really have to change it to scientific notation. And actually, this should be to the 4th. Let me write it again. We have to go out to here, so 1.02. So first we have to get 3 significant figures and then change it to the proper, I was off the page, sorry, to the proper scientific notation. Okay. We have 4. This lecture is going to go over 10 minutes, unfortunately, but I think it's best to have a continuity here, so I'm not going to chop it up. A compound has a density of 7.35 grams per cubic centimeter. What is the volume in mils of 15.3 grams of this compound? So use the same equation again. We're given density, we're given mass, we have to find volume. So if we were to rearrange, put it into this form, and then isolate volume on the other side. Now that's the equation that we want to use. So one thing you should realize is that Even though we have this equation and then we can solve for mass and we can solve for volume, it's the same equation. We just manipulated it around a bit, so I should get used to doing that. We have the mass is 15.3 grams. The density is 7.35 grams per cubic centimeter. They want the volume in mils, so once we find, you can see that grams will cancel. Then it's 1 over cubic centimeters, so we should end up with cubic centimeters for our answer. So we have 2.08 cubic centimeters, and that cubic centimeters are also mils. So that's our answer. All right, and then another question we can do, another problem. A compound has a density of 8.88 grams per cubic centimeter. What is the volume in liters of 11.6 kilograms of this compound? So this problem is set up so that you have to find a volume in liters that's different than this volume. And you have grams here, and you have kilograms. So we got a lot to do. But what we're looking for is volume. So volume is mass over density. And but we need to have the units of mass and density match up. So we have grams here, we have kilograms here. We could change this to grams, or we could change this to kilograms. I usually change this to grams because I just find it a little confusing to do that, to change this to kilograms, since density is generally found in grams per cubic centimeter. But it's up to you. But you need to have the same units of measure. So 11.6 kilograms, 1 kilogram is 1,000 grams, so that's going to be 11,600 grams, or 1.16 times 10 to the 4th grams. And so volume is going to be 1.16 times 10 to the 4th grams divided by 8.88 grams per cubic centimeter. So grams cancel. And there's a cat here. 8.88. 1306.306. No, kitty cat, get out of the way. Then we have 3 significant figures for both. So this is 1.31 times 10 to the 3rd cubic centimeters. And we want that to be the volume to be in liters, so that's going to be 1.31 liters. And I did that conversion pretty quickly, but we've done it before. So a lot of stuff there, but that's about as tough as you can make the problem. Here's another type that comes up where once you find the density, you have to determine if the substance you're dealing with is a particular kind of substance. Happens a lot, where you find the density and you have to determine the substance from a table of densities. Here it's a little easier than that, but same kind of thing. So we have a sample of metal that is thought to be silver is found to have a mass of 15 grams. The volume of the sample is determined by water displacement and is found to be 0.700 mils. Is this likely that this metal sample is silver? The density of silver is 10.49 grams per cubic centimeter. So I say likely because even if it has the same density, it doesn't mean that it's silver, but that's the first check that we would have. If the density was not 10.49, then it definitely isn't silver, but at least that puts us on the right trail if the density comes up correctly. So we want this density, we're given this mass, this volume, so 15.0 grams, 0.700 mils. And we come up with 21.4 grams per mil. So we find that 21.4 grams per mil and is equal to 21.4 grams per cubic centimeter. And this does not equal 10.49 grams per cubic centimeter, not silver. And You could have also been given this, you find this density and then be asked to determine what metal it is, and you'd have a list of metals, and one of them would be either 21.4 or very close to it. And that's the deal.